2 questions will be missing. Maybe I'll make a short video of those. Sorry about that, guys. That's why that symbol was on there, to remind me to hit record. Now we're recording. Okay, so we want to factor this trinomial. You can do your signs first. Remember, look at the last sign. If it's plus, your signs will be alike. They will be the sign of your middle term. So they're both going to be plus. Split your z's. We're multiplying to get 20 and adding because they're like signs to get a 9. 5 and 4 would probably pop in your head. If it doesn't, make your list. And so we can throw those in. Double check with outside and inside. I'm not going to write it here because it'll be in the way. So 4z plus 5z, yes, that gives me 9z. And then with the zero product law, once you have a multiplication here, so a product, you set each piece equal to 0. And solve. So for the first one, we are going to subtract 5. So we have z equals -5. And this one we will subtract 4. So we have z equals -4. 2 answers. So normally we would put these in braces, -5 and -4. Any question there? And I'm not going to type those. We'll just check the answer. So we're good there. All right. I did pick the next one just to remind you about trinomials. And this one is not a nice trinomial because its leading coefficient is not 1. And so we still would get the 0 first. So move your 10 to the other side, add it to both sides. So we have 3x squared plus 11x plus 10 equals 0. And they have said to solve it by factoring, which is a hint that it will factor. Normally, if I get a trinomial with a leading coefficient that's not 1, I will go to the quadratic formula. Just because if it doesn't factor, it could have been a lot of work. All right, but they told us this one will factor. I'm going to show you 2 ways to factor this. And so either way that you learned, you can do it. You don't have to learn a different way. In my classes for 1033, I usually show it as trial and error. And so it is going to go into 2 binomials. It comes out of a FOIL. Right? And so it's going to be like signs both plus. And you have to multiply to get 3 here. So 3 is a nice number because it's a prime. You're going to have to use 3 and 1 and still split your x's. For your 10, you have 1 times 10, 2 times 5, 5 times 2, or 10 times 1. And you can no longer look through the list and see what works because this spot is not 1. When you check, it's going to multiply by whatever is on the end. So if you try them, the 1 and 10 is not going to work. So you would throw them in, and outside you're going to get 30. Plus 1 is 31. So that doesn't work. We could try the 2 and 5. That looks a little more reasonable. But we get 15x plus 2 is 17. That one doesn't work either. So these don't work. So we'll try 5 and 2. We'll say no on this one. It did not check. And so we'll keep the 3x and the x. And we'll switch into 5 and 2. And here I have 6x on the outside plus 5x. That is 11x. So this one works. We'll go ahead and solve it from here, and then I'll go back and show you the other way you could factor these. Right, so this is also the zero product law. Set each one equal to 0. And solve. So our first one here, we have to subtract 5 and then divide by 3. So a 2-step. and then you'll divide by 3. So we get a fraction. This one just subtract your 2, so we get x equals -2. So our answers, let's see, that -6/3 would be -2. So -2 first. These should just go in numerical order, but it doesn't really matter. It's not going to mark you off either way. Right, that should be our answers. And it is, so we're good. And they put the braces on, so you don't have to put them on. Now I want to just take a minute and go back and show you how you can factor this by turning it into a grouping problem. And I know several of my students, even from last term, also did that technique. So this is just a little sidetrack into factoring. If I scroll though, that is going to go away. Let's see. It's okay, I can rewrite it from the other side. You know what, we'll just do a new page. And I'll go ahead and put it in standard form. Right, and sometimes this way is called the AC method. Sometimes it's called to factor it by grouping. What you do is turn it into a problem with 4 terms. You're going to split this middle term into 2 and turn it into 4. The 3 is your A and the 10 is your C. You're going to first multiply those. So A times Z is 30. So it's this one times this one. All right. Out of things that multiply to give 30, you're going to get the 11. On the other kind with a 1 in front, you just looked at this one. You didn't look at this one, but it's because it was a 1. So the 3 comes into effect in that. So we have 30. We can do 1 times 30, 2 times 15, 3 times 10. 4 doesn't work because you get a remainder, and 5 times 6. You don't have to do both orders right here. So what you can do now is look at the list and see how do I add, because they're going to be like signs, to get 11. It's going to be 5 and 6. And so we're going to split this 11x into 5x and 6x. You're going to bring down your first and bring down your last. So this one I'm keeping. Now I'm going to do it by grouping. So I'm going to put the one there that has something in common. And I will put an x with it. Right, I'll put the other one here. And the 10 is just coming down. These 2 in the middle are supposed to give you 11. They do. Now you forget that it was a trinomial and factor it by grouping. So here we could take out 3x. And that leaves us x plus 2. Here you can take out a 5. And that leaves x plus 2. You did get the common binomial, which you expect with grouping. And then you pick up the missing pieces that are outside. So that is just an alternate way to factor those trinomials. Then you would go ahead and solve. Any question there? All right. Let's go ahead to our next problem then. And I picked number 4. Right, so when you see this, you see the equals, you know it's an equation. You see the exponent of 2, you know it's a quadratic equation. Your first step would be to try to factor out something, and you can factor a GCF on this one. So we will choose a negative GCF because the first term is negative. So I'm going to choose a -5 P Remember when you do GCF, it's one set of parentheses? So to get back there, that leaves me a 4p, and we took the negative outside, so this is going to be plus 5. We've already got the p. Just kind of double check it in your head. So negative 20p squared, we're good there. And negative 25p, that one's good. And now we set it equal to 0 and solve. So this is also the zero product law. So we set each one equal to 0. And this one you're going to divide by negative 5. It's still going to give you 0. Don't throw 0 away. 0 is an answer. Right? And for this one, subtract your 5. So we have 4p equals negative 5 and divide by 4. So p equals negative 5/4. So you have two answers, negative 5/4 and 0. And we'll just look at the key. So 0, negative 5/4. Any question there? Right. Then we're going to switch over and look at our next technique, which is the square root method. We'll do problem 5, but before we do it, I want to do one that's a little easier. This is a kind of a mean problem for square root method. They didn't start you out nice and easy, so I'm going to give you one that is a little easier to remind you about it. So, square root method. To use this technique, you need a certain setup. You need something squared equals a constant. And then you'll take the square root of both sides, and remember you'll get plus and minus on this side. So x will be equal to plus or minus the square root of k. And then you do whatever you need to solve. Now this could be a binomial. It doesn't have to just be the one piece, but whatever it is, the whole thing would need to be squared. So I'm going to do one problem before I do problem 5. This one is not in your work. I'm just going to do x squared equals 20. This is an exact setup for this. Whenever you don't have a plain x term, right, is a good setup for this. And so take your square root of both sides. So x is equal to plus or minus square root of 20. And 20, we need to simplify that radical. So we'll do it on this side. I like to do those by primes. So we have 4 and 5. There's some 2's and a 5. So 1, 2 can go outside the radical. And it will go right against the radical when we come down. 2 times square root of 5. And there is no plus and minus in this note in the template for the answers, so you have to separate it and write them both. All right, now we'll do the problem that's there. So the problem 5.
In that case, would the 2 always be on the inside of the plus and minus as well because it's connected to the square root?
It would be right against the radical, so it would be after the plus or minus.
Okay.
And we will see one where you'll have something on the other side of it in a minute. So good question. All right, this one. If it didn't tell you that you're going to do this by the square root method, you might think, oh, I better get them on the same side and factor, which you certainly could do something there, because you could move the 40 over and you could take out some factor and then see how you could go from there. The reason that I think it's good for square root is because it does not have a plain n. It has n squared and constants, but no plain n. So if you have that set up, square root method will work. I need to get my square term all by itself before I take that square root. So I need to move the 38 to the other side. So 6n squared equals 78. And I need to get rid of this 6. Now, if it doesn't divide evenly, it's not going to be so nice. But it actually will. And this will go 13 times. All right, now it's a piece of cake for a square root method. You'll take the square root of both sides, and so here you'll just get n equals plus or minus square root of 13, and 13 is prime, so it will not simplify. Right. So it ended up easy here with the solving, but you had to do some stuff before you got there. So you don't want to do square root method until you have the piece that's squared all by itself. Okay, let's see if we have the right answer. Good. You just have to split it up there. All right, we will also look at the next one. And this one has a binomial squared. And it is actually ready to go ahead and take the square root of both sides. I feel really bad when I see students multiply this out with FOIL, which you certainly can do, and then you can solve it a different way, but it's a lot more steps than you need. This one is a setup for the square root method because it's something squared equals a constant. So take the square root of both sides. You take the square root on this side, and I'm going to write the step here. I'm doing square root of both sides. It gets the exponent off. So I've done a square root on both sides. And that leaves me x plus 10 equals plus or minus square root of 13. Again, the 13 is prime, so it's not going to simplify. I do have one more step. I want to get x by itself, so I need to take off this 10. I'm going to subtract it, and you should do that in front of the plus or minus. So that gives us x equals negative 10 plus or minus square root of 13. Especially with software, the reason I say to put it in front, and that's standard, is because if you are not out from under that radical, it would pull part of it under the radical, and then it's a whole different answer. So we can enter this one. You just have to separate it. So I'm going to do negative 10, and I would have to put the plus. You don't want that to just go right against the radical, because then it is multiplication. Right. Now, this is where I need to get out from under that radical before I put my comma for the second one. You can click at the end of it, see how the cursor moved, or you could use your arrow button, I think. Arrow button from here or the keyboard. All right, now I am out from under the radical, and I'll put the other one. So negative 10, and this one should be, I did plus first, so this will be minus. And if it tells you syntax error, that's a clue you're typing something in wrong. Good. Right, next I went to quadratic formula for problem number 9. And they told us quadratic formula. This is one you could try to factor. But I would probably choose quadratic formula even if it didn't say it, because it is one that takes a little more work to factor, and there is the possibility that it won't factor. All right, so we'll do it with quadratic formula. You need to be in standard form, and you want to pick off your coefficients A, B, and C. And I like to write those. So my A is 4, B is 3, and C is -4. Right, and we have a formula which you need to know. So x is equal to -b plus or minus the square root b squared minus 4ac, and that whole thing is over 2a. And then it's a matter of substituting, being careful with your arithmetic, and cleaning up. So if x is equal to -b will be -3 plus or minus the square root 3 squared minus 4 times 4, and then c is a -4. This whole thing is over 2 times 4. Now we have to clean up, so we'll work under the radical. 3 squared gives us a 9. And here, I always go ahead and double check my signs. I have 2 negatives, so that is going to be a plus. And then I can do my multiplication. So 4 times 4 is 16, times another 4 is 64. And it's okay to go ahead and multiply the denominator. It's an 8. And I need to clean up under here. So -3 plus or minus. And this gives me 73. I don't think that 73 will simplify. It's not even, and it doesn't end in 0 or 5. I don't see anything there. And I don't know if you ever saw it or not, but a divisibility trick to tell whether a 3 is in something, if you add these up, you get 3 and 7 is 10. If 3 won't go into 10, it won't go into 73. So that is just helping me to know that I think it's simplified. So you would have to split this one up to put it in. So it would be negative. Let's enter it, because a lot of times that is what is the issue for you guys. So we do have the right answer. That's important. You need to do the fraction button first. And so you have -3. And we'll do plus from the keyboard. Square root 73. We'll go down to 8. And you have to get out of that denominator, so you can click at the end or you can use the arrows. Now I'll do the comma and a second fraction. So I still have -3 at the beginning. And this one should be minus square root of 73. And then I want to go down, and then it's an 8. Good. You guys feel okay with quadratic formula?
Yes, just have to
Yeah.
remember the
Okay.
formula.
Okay, very good. All right, I am going to go then on to, you know what I'm going to do before I go there? They switch it up here, and starting at 12, I'm not going to work these. I'm going to mention which techniques would be okay to try, right? Because that's hard for some people. If it has a plain x term, you're not going to do square root method unless it's in that parentheses. So we'll just look at these and kind of say which method it would be. So for number 12, you have two choices. You want to get your 3 on the left-hand side. Go to standard form, and you could try factoring or quadratic formula. And you could try either one. The possibility is there that it's a little more work, and if it would not factor. 2 is not huge, so, you know, it's a toss-up. You can choose. 13, I would definitely go with square root method because you don't have a plain G term here. You have something squared equals a number. You have to get the 4 off first, so divide by 4, but then go with square root method. $14, you're going to move your 85 over. It looks like a great one for factoring. If it doesn't factor, then go to quadratic formula. And I think actually this one doesn't factor. It's a nice trinomial, but that doesn't mean it will always work. I think I looked in the answer and it is has eyes. So that means you get a problem that won't factor. And in your quadratic formula, you get negative under the radical, which is your I.
A quick question.
Yes.
If we do get an I, which is like a negative, do we have to factor it out and put the I there, or can we put like the radical negative? That makes sense.
You need to take the I outside and put it in front of the radical. Because I is square root of -1. You want to take that out every time. Let's do that.
Okay.
I have enough time. That's why because I only had one more problem picked for you guys. So we can add in a problem here. And
Thank
it
you.
doesn't look like it would be a big deal. So we would move the 85. And then I normally would try factoring. It doesn't factor, so we'll leave that. You would go through the list of things that multiply to give to 85. And you're just dividing into 85, making your list. And we can do that. So 1 times 85, you need a calculator. 2 doesn't go because it's not even. I know that 3 doesn't go because those don't add up to something that 3 goes into. So none of your even numbers will divide into it. 4 won't go. 5 will go because it ends in a 5. And I think I pulled that over top of my calculator. Not sure how that happened. Oh, because I got it down too long. Okay. So we'll just do 85 divided by 5, 17. 6 will not work. None of the even numbers will work. You have to try 7. Doesn't work. 8 won't work. 9 won't work because 3 didn't work. 10 won't work because it doesn't end in 0. And we're probably to where it would turn around. We could try 11. Right, didn't work. You could try 12. No, you would not try 12 because it's even. You would try 13. Doesn't go. 14 you would skip. 15 you could try. Actually, 15 won't work because it has no 3. So you'll get a remainder. 16 you want, and then you're going to get 17. So then it's going to turn around. And so that is the only choices. And those are not going to, let's see, like sign says they're going to add. So those are not going to add to give us a 14. So that's why the factoring doesn't work. So then you go to quadratic formula. We'll still need that calculator for quadratic formula. A is 1, B is negative 14, and C is 85. So the numbers are not going to be pleasant, right? So I'll just put my formula real quick. X is equal to negative B plus or minus the square root, B squared minus 4AC all over 2A. And if you say that out loud as you write it to yourself, that will help you remember it. So when you plug in your B, this says negative B, so this will actually be a 14 here, plus or minus, and this negative will go to the power. Minus 4 times 1 times 85 over 2 times 1. So 14 plus or minus. Sorry, you have to get off of my calculator. So negative 14 squared, and the negative will make it positive. The square will make the negative positive. So we're going to do it to the second power. 196. And here I have, this is going to be negative. You only have one negative. And we have 4 times 1, which is 4 times 85. 340. We can see right now that this is going to be negative under the radical, which tells us, it's a heads up, there's going to be an I there. So let's see if I can get that to roll a little bit. So 14 plus or minus 196 minus 340. Negative 144. Oh, this one turns out nice, even though it took us on a little ride. Right? 144 is a perfect square. It's 12 squared. But the negative is an I, square root of negative 1. So you're going to take that out, and this will be 12. And normally we would write 12I, but the I would go right against the radical, if it still had the radical. This is going to clean up, because in your pieces here, around your plus and minus, these are all even. So you are going to divide by 2. So 2 into 14 will go 7. You still have your plus and minus. 2 into 12 will go 6. I'm going to just switch the order because we're used to seeing the I right after a constant. And this 2 divides out. So we have 7 plus 6i, or 7 minus 6i.
Okay, so anytime that there is a negative, there's always an I right behind it, like laying behind it, if you can factor it.
Yes. And if it still had a radical, I would put it in front of the radical, because if you put it and it accidentally gets under there, then it's going to be wrong. So you're always safer to put it in the front. Since it ended up being a plain number, I would put it after.
Okay, so like if it was like something that couldn't be, like if it was like a radical negative 3, then it would be I rad 3.
Yes.
Okay, perfect. Thank
Exactly. You are very welcome. All right, I'm going to work on this thing for a second and see if I can get this back up where it should be. It shouldn't be so long. All right, we'll just leave it for one more problem. I will fix it tomorrow. It shouldn't be down there covering up my things. And I just didn't want the calculator in the way. Right, and I didn't even check so you could see the answer on that. I picked 17 out of these rational expression ones, so we'll look at it. And it is something you've done before, but just a reminder. It was kind of at the end of the intermediate algebra class when everybody's tired. I'm going to just move that one over a little bit. Right. So what we want to do is clear out the fractions. So we need to find the LCD. So we need to factor this denominator to see what it's made of. Hopefully it's x minus 4, x minus 5. And it actually is. Right? And then, because there are variables in the denominator, you have to look and see anything that would make the problem undefined, and you need to throw that away. So what makes it undefined is you can't have a 0 in the denominator. And so we're going to set each denominator equal to 0 and solve, and that's what we will throw away. A lot of times you can look at it like this one, you can look at it, it's 4. 4 is bad, it would make a 0 here. 5 is bad, it would make a 0. These use the same pieces, so it's going to be the same ones. But if you get stuck and you don't just see it, if it's 2 steps, it's not so easy to see. Set it equal to 0, solve, but remember you're throwing that away. So we're going to put that up here and then not think about it until the end of the problem. So it will be 4 and 5. We have to make sure our answer is not one of those. Right, next you need your LCD for the problem, and you have to cover every type of denominator, and fortunately both of these are included only one time in this one. So this big piece is going to be your LCD. So we are going to multiply on top by that whole thing. So I'm going to go down a little bit and get us some space. So I'm going to multiply times each one on top because I want to make all my denominators cancel. And this last one, it is going to cancel everything. I'm going to write it sideways a little bit because it will cancel all of it, so it won't matter that it's sideways. All right, now we're going to clean up. So x minus 4 is gone. This is going to distribute and clean up for us. Let's go ahead and clean the rest. This one's gone, and this one will cancel the entire denominator. So let's see what we have now. We have x squared minus 5x. This one, your 4 needs to distribute. You always have to watch on these. Whatever this sign is should go with this number when you distribute. Right, but it's plus, so that's good. I don't have to worry. So I have plus 4x minus 16 equals x plus 47. So my fractions are gone now. The denominators are gone. And I will move everything to the left-hand side, I would probably clean this up first. We'll clean it up first. So it's minus x minus 16. Now we'll move them over. So if I subtract an x, that's going to give me minus 2x. And I'm going to subtract a 47. And those are like signs, so they're going to add. And that is giving me 63. Over here it says 0. This is one that will factor pretty nice for us. It's a trinomial, and you might see 9 times 7 will give us 63. So we'll factor with those. We're going to have different signs. And the sign that's in here needs to go with the bigger number. So minus needs to go with the 9. And then set each one equal to 0 and solve. So this one's going to be negative 7. This will be positive 9. And I should have checked that factoring first to make sure it worked. Just did. Now you have one more step. You have to go back and make sure you didn't throw those away. And unfortunately, I scrolled. We'll keep it in our head, negative 7 and 9. What I threw away was 4 and 5. If you had thrown it away, then you could not count it in the answer. It would be considered extraneous. But these were not thrown out, so these are our answers, negative 7 and 9.
Mrs. H, I have a question.
Yes.
I don't recall in our last class if you actually ended up using the throwaway numbers. What happens if you get that? Do you have to rework everything, or would it be a 0?
No, it would be no solution. So sometimes with quadratics, you might have to throw away one of them. And this one was a quadratic. Sometimes you have to throw away everything. And if so, then you would choose no solution. You wouldn't go back and rework. Right? So that would tell you if everything cancels, if everything is thrown out that you're getting for an answer, you would say no solution.
So if if that 9 was actually a 5, then the only answer would be negative 7?
Correct.
Okay. And then one more question.
Okay.
With the double negatives, like the x squared minus 2x minus 63, when you factored it,
Yes.
that negative, you said it goes with the higher number. Is it always like that?
When it is a trinomial that has a leading coefficient of 1, that is true. Whatever sign is here on the middle term will go with the bigger number.
Okay.
Because that's the kind you want back when you check. So it goes with the larger.
Okay. And then if I made a mistake, I can always just go back because I'll check it and then I'll see that it was wrong and I can always flip them.
Right. And I should have checked before I went on. That would be what you would want to do. Any other questions from you guys? All right. That is all I picked out. So if you feel good, we'll stop there. So if you want anything, you need to say. All right. So we'll stop there. The college is closed Monday, but you can still work on your things. And then we will have a session on Tuesday. And make sure that you watch your videos for that next lesson. Those are a little tough in that next lesson, the 2.4b. So actually it's 2.5a that's a little hard. 2.4b is not hard. All right. Thank you so much for coming. You guys have a great weekend.
Thank you, Mrs. H.
You're welcome.
Hey, Ms. H. So this class is Tuesdays and Thursdays at 1?
Yes.
Is that correct?
Yes.
Okay. And I'll be needing a TI-84 calculator, right, for this class?
You can get either a TI-83 plus or a TI-84 plus, either one.
Okay. All right. Thank you so much.
You're welcome. I'm glad you joined us, Nick.
Thank you. Thank you. Bye-bye.
Bye. All right. I'm going to turn off the recording, but I'm going to hang out.